developing that project is that it's one thing to create a security engine. It's completely different things for the users to create policies and rules in the context of that security engine. The topic that we are going to dwell on today, talk about, is how do you simplify that usage? Like, what is it that we can do in the context of not letting user deal with the complexity of specifying those in-depth specific rules and policies in the context of a specific policy engine. So I'll hand it over to Ravi. He'll explain the premise and then I'll talk about the actual architecture in detail. Ravi, go ahead.
Thank you, Rahul. So before we start the topic, right, there is a word here like intent, right? So what does intent mean? Basically, from childhood we have the intent, right? Like I want to secure good marks. I want to secure 90% marks, right? But I have to study for that. So that's my intent, right? So let's suppose what are the arsenal for that to securing a good marks? You have to cover, of course, syllabus. There is a particular syllabus in that, and books are the arsenals, or you can say the tools for it, right? So the thing is, for any intent, right? The prerequisite, you have to do some prerequisite, right? So that's where this comes, security intent automation. We want to automate that intent, right? Without doing so much effort. So moving on to first slide, Kubernetes is hard and Kubernetes security is even harder. As highlighted by Cloud Native Security White Paper, we are dealing here with multiple layers. With different layers, we have different challenges as well, right? In Kubernetes, we have multiple layers like host, pod, container, runtime, network, storage. Each layer deals with lot complexity, and we have to consider about compliance, policies, and we have to apply it in different layers. So it's not quite possible to use a particular tool, one tool, to get the job done. And on top of adding with the changing workload, right, where we have the communication to external world, we want to change the scenario, etc. So it's got not possible to get into the security accepted. So here you can see from CNCF community we have a lot of tools. In this phase only, like we have more than 110 tools. Each tools are meant for some specific purposes. Like we all know OPA, Falco, Kyverno, Cube Hunter, Trivi, right? So basically, all those tools have different purposes. Some used for admission controller. If you want to get the compliance, we use Kubepage, Cube Hunter. Some are from container security, like Trivi, Player. And the thing is, these projects, right? If you want to secure a cluster, if you even deploy all these tools, this will occupy all the spaces. Still you're not sure that whether you are secure or not. So a general approach, right? How do we secure our Kubernetes? Basically it drills down to two phases, right? Like understand which arsenal I want to take over, right? The security engines or security tools. And then recognize policies for that. Basically they can give you a particular recommended policy or discovered policies. But still, like we have a lot of challenges out there. Let's suppose you choose one particular tool, right? And the licensing got changed, or the management decided like you don't have to use this tool. Now again you have to train your SecOps to deliver those. So there could be technical challenges, non-technical challenges, right? And there is always scarcity, like if I switch from one tool, what do I lose? In this example, right? Like if I'm using Cilium and then I switch to Calico, let's say open source, then what do I lose? One thing is like you will lose L7 visibility, because in Calico Enterprise you have L7 visibility, but in Cilium, in open source, you have that as inbuilt. You can't achieve defense in depth using a particular one security toolings because of the different layers are involved in that. So you have to be dependent on different types of the tools as well. And as I said, right, the dynamic workloads, you want your container not to go in rogue, or you want privilege control on that container if it is connected to internet, but you don't want that kind of restricted environment if it is hosted internally, like it doesn't have the communication to the world. How to handle these fragmentations? So we have, one can create a standards, right? Like there is a saying like, okay, how many standards are there? Like, there are 14 standards. Let's build one particular standard that solve all the use cases. But eventually, what we see, right? We end up having 15 standards, and again the story continues, right? So we have a lot of standards. Like let's say, for example, we have netball, SMI, spec, right? The advantage of using a standard is it is easier to explain to the user and easy to manage, right? But there is a problem as well. The innovation is happening at much faster rate than standards are being adopted by devs. One example, like we have network policies, right? But we want different layers of security, so there are other providers, Cilium network and Calico network, and it happens with every service mesh vendor, right? So, moving on to next slide, how Kubernetes solves this problem, right? They also have this problem. So, the biggest problem that Kubernetes solves is storage class operator. So, I mean, like you just define the service level agreement to the Kubernetes that, okay, I want 100 GB disk space and multiple read, single write access with this speed. And you don't do any policies in that, right? Basically, you define the service level agreement, and under the hood, Kubernetes go and check which volume to bind, and it eventually gives you the persistent volume claim so that the pod can use it. Can you imagine doing this when you deploy a cluster, like go manual and specify like I want to do this? It's not possible, right? So this is how the Kubernetes solves this problem. But can we do something in security as well? Like there are a lot of tools involved or deployed on my cluster. Can I get security like just by providing my intent? So the scenario is this, right? As a security ops, I want to just decide. I want to just give the intent, and there will be some operator which looks for that intent. Okay, this is my workload that I want to secure. This is my infrastructure that I want to secure, and it will vary whatever the policy engines are deployed there, and eventually get us to the policy. So I will hand over to Rahul for.
Thank you, Ravi. Thank you. Thank you, Ravi. So, what happened is, what Ravi talked about is, can we use something, a Kubernetes native design for security, simplifying the security itself. The primary problem being today, users are actually deploying security engines and the corresponding policies. What users care about is their security intents. And as you can see, this is one of the projects that we are working on. It's in collaboration with. It's not in collaboration. It's sponsored by National Science Foundation in US, and it's in collaboration with Stanford Research and Ohio State University. The project name is called Nimbus, and the aim of this project is how do you simplify deployment of security intents, and the primary use case is 5G security, 5G ORAN security to be very specific. As you can see here, as you go from left to right, the complexity increases exponentially, right? And the aim of the project is to allow users to specify the security intent at a high level, and then the actual work is done by a Kubernetes security operator under the hood, so as to create the security policies and rules in the context of the intents that is specified. So that's essentially the gist of the problem statement here. And then once you have this mechanism, you can then create blueprints out of it. All of a sudden you can have a 5G ORAN blueprint, 5G core blueprint, enterprise blueprint, healthcare blueprint, and as a user you're just specifying, oh, these are the intents that might be applicable in the context of my deployments. Take it, push it to the operator, and the operator will make sure that it checks what are the deployments are available, what are the security engines are available in the context of a specific deployment, and then deploy the corresponding policies and rules. It's easier said than done. Basically, the blueprints are essentially a vertical specific bundle of intents. The intents are something which is a high-level intents, policy engine agnostic intent. And then comes the policies and rules. That is the thing that is completely abstracted away by the whole framework. We don't want users to deal with the final end policies and rules. And this comes back from our own experience of developing a policy engine and checking how difficult in general it is for the users to create the specific policies and rules. It's not easy. That is why most of the time the security solutions don't get adopted in the first place. I won't go into the detailed architecture here, but the one message that if I have to send across is that storage is much more complicated than security, I would say. And the best thing to happen that happened in the context of storage is the storage operator, which essentially completely abstracted away the complexity. As a user, you specify the SLA in terms of, do you want read once, write once, read only storage, what kind of SLAs, do you want SSD? You can specify at a very high level. The storage operator under the hood takes care of deploying the appropriate block devices and things like that. You specify PVC and the volumes are automatically selected to you. The same thing we are trying to do in the context of security here. There is a security operator here, and the security operator waits for the intents to be deployed. And when the intent is deployed, it checks, oh, admission control is available, we can do this. Kubernetes engine is available in the context, we can do that. Oh, CNI is available, network policy can be deployed, so we can do this. This is the intent, we can convert this intent into this particular policy, and then have the security fulfilled. And so, if the most important, if I have to talk about the most important design rationale, that would be the point number one. We wanted to keep intents completely agnostic of the policy engines, because if it becomes policy engine specific, we are essentially developing yet another policy engine, which does not make sense. So we wanted to keep that intents completely agnostic of the policy engines, including the parameters. Now, all of a sudden, once you do this, you have an operator which is then converting the intents into policies. The operator is now converting these intents into policies at multiple layers. And that is what Ravi was saying. You get defense in-depth strategy out of the box. You have an intent, that intent is converted using admission controller policies into Kubernetes policies, Falco policies, Tetragon policies, CNI policies, and all of a sudden you get defense in-depth out of the box without the user having to specify these policies individually. There are a lot of design choices we had in mind, but the primary thing that comes to my mind is we had a big decision to be made. Why can't simply an admission controller take care of this particular problem? You know, the biggest challenge with admission controller in our case that we faced was that we wanted visibility at the runtime. We had certain use cases where the intent operator could dynamically change or adopt a policy in the context of dynamic situation. For example, if it sees that a workload is actually exposed to internet, then there are certain intents that might be applicable in the context of that workload. So it needs to have this visibility. An admission controller cannot give you that visibility. You need an operator operating at runtime. That's the primary design rationale. And again, I'm skimming through the slide deck here so that I don't keep you away from your lunch. So please bear with me. One specific example, or a couple of examples rather, I would like to give is, an example here is preventing DNS manipulation. A typical intent applicable in a lot of scenarios, including 5G core. And this intent can be fulfilled in multiple ways, right? Like as a user, you specify the intent, the Nimbus operator sees, oh, there's a Kubernetes adapter in place. Let me check what a Kubernetes adapter can propose me. And it says that, oh, for DNS manipulation, you should not allow anyone to update edit result.conf. That is one of the attack surface. Do not allow use of raw sockets, because that is how another thing that comes to attackers usually leverage. When it comes to CLAN adapter or a network policy adapter, a network policy can as well emit a policy saying allow DNS request emitted to only specific endpoints which are related to local DNS. Right? Like you can have this network policy, system policy created out of the box from a single intent, which automatically provides you a defense in-depth strategy out of the box. The same example, a similar example rather, software deployment tools. A lot of times, the applications are shipped with containers having package management tools. It's surprising, but by default, even Alpine ships with APK tool, which allows you to deploy runtime accessory tooling. Most of the times, attackers make use of these accessory toolings to install their additional tools that they need. For example, masscan. We know that a lot of attackers actually download masscan at runtime to attack the corresponding cluster. So typically there is no need for someone to actually use these kind of deployment tools in runtime. So how do you protect it? Like you have a kubearmor kubearmor adapter, which can generate a policy saying do not allow these package management tools to execute in the runtime at all. And that's that's the speciality of that particular policy engine. It can actually deny from that getting executed. And in case of Cilium or network policy adapter, you can see that certain API resources over the internet should not be made accessible at all. So automatically you get defensive strategy. This is a security intent schema, and the reason why this schema is important is because we are working with multiple other providers, platforms, to create blueprints, out of the box blueprints, which can be adopted in the context of specific verticals. So if you have to do that, you need an intent schema to be in place. And this is a sample intent schema. I won't go into the details of this, but there is something specific. The detection methods, mitigation methods, these are some things that we have not innovated. It already exists in a lot of frameworks. For example, MITRE ATT&CK framework, it already tells you what is the detection method, what is the mitigation method in the context of a given tactics, techniques, and procedures that an attacker might use. So a lot of that tribal knowledge is getting used in the context of attacks here. Immediate goals for Nimbus. Nimbus is the name of the whole framework. Our immediate goal is to first work it out in the context of 5G security, because that's the mandate that has been given to us by NSF. So that's the number one priority, and we are executing that in the context of Nephew. Nephew is a community project from Google. It's a LFN project, Linux Foundation Networks project today. The other aspect is Red Hat Telco. We are creating blueprints, working with the Red Hat, Juniper, Intel, Rebecca, and other teams together to create blueprints not only for security but for the whole ecosystem. And then Tata Elxsi has a platform called as Neuron, which essentially talks about automating networks deployments, and security is one part of it, one dimension of it. You'll see some of these demos in MWC very soon. I'll hand it over to Ravi. I think we should be able to fast forward the demo here, but yeah, Ravi.
Thanks, Rahul. Yeah, thanks, Rahul. So basically, a user will specify the security intent, and security operator will check for the workload, and from using the policy engine, right, it will create the policies. So as you can see, our this is Nimbus deployed using operator and adapter, and above we have the kubearmor and sample workload is deployed. So here user have specified the intent. This, suppose an example for the intent is block SS token for Kubernetes service token, and prevent DNS manipulation, and respective intent binding is here as well. So after applying this intent and security intent and binding, it is got created. Now let's verify this, right? So here we see there are 3 policies are created, security policies, and 1 network policy created for our 3 intents. So basically, let's describe the security policy. So first intent was like, so the first intent was to block the package manager. So you can see from the kubearmor, right? We have these policies created, which will block the package manager in a runtime environment, right? So let's see this in action, right? On the right hand side, I'm listening to the log, and now the policies has all been also applied, and now I'm trying to execute that particular command on the left hand side. And as you can see, right, once I use app update, the policy got enforced and it blocked the logs for that. Similarly for DNS manipulation, right, we have basically 2 policies that has been created. The operator figures out, okay, we can do this by a network and also system as well. And you can see the policies for network up here. And the third one, right, the service account token. So basically, this is the path, right? Let me show it to you down below. So basically, this path is shared among all the bots, right? So here it will block that particular service token. So in a nutshell, right, you don't have to do anything. but your intent got satisfied, right? So in short, like you can pass the exam without studying, doing all the hard works.
Well, everyone knows that is not true, but okay. So if you want to see the demo in detail, please visit our booth. We have Kubernetes booth in the securities track here. So we'd be happy to take your questions now. Yes.
When you say this tool, right? Is this an orchestration layer on top of all the services?
I won't call it as an orchestration layer per se, but it's a Kubernetes operator, which basically understands the intents and converts the intents to specific policies given. I won't call it as an orchestration engine. Orchestration engine is basically doing scheduling pods, doing a lot of other work under the hood. It's not about that. It's making sure that the intents are converted into appropriate policies and rules using the security operator. And security operator doesn't have the knowledge by itself. It leverages some of the adapters that are prepared. And we have created adapters for Kubernetes, for CNI, for service mesh, for admission controllers and things like that. And that has all those heuristics, even the intent, how to convert it. And that is much faster to be innovation. From innovation perspective, it can be much faster.
Basically, it uses the network policies, then you apply it.
Yes, so eventually you specify intent at a high level, prevent DNS manipulation, that's an intent. Under the hood, network policy can be used to fulfill that intent, and that policy automatically gets enforced at the cluster level. The reason why this is important is because in the context of 5G security, you have edge clusters in thousands. You cannot really manually enforce all these policies and manage all this complexity. You need automation to a next extent, and that's where we are going.
And when you said that it can understand, like for example, like a web workload which is going to internet, right?
Yeah.
It can understand and it can give you that option?
Like I said, the heuristic is not built inside the operator itself. Operator leverages certain outside solution. For example, within AccuKnox, we have developed a solution which can see, these workloads require access to public internet. Let's annotate that workload with specific annotation. And that annotation is made use of by the Nimbus framework to say, hey, if this annotation is present in the context of this workload, these policies make sense to me. That automation is present as part of that.
Okay.
Thank you.